Hi, Bella. I'm exhausted and it's not even 9:30. Oh man. Okay, we crashed twice today. What a terrible day. God. If we could just finish this problem. I'll wait till we get another 10 of you, Bella, and then we can start up. Oh, really? I just want to finish a chem problem. All I want to do. Hello. Sorry I crashed twice with you. I do not know what the deal is. That's never happened. Thank you for finding me again, everybody. Let the others know on our chat, would you, that I'm on again. Maybe give a quick text to the others. Thank you. Thanks for joining me again. I'm getting everybody back. Yeah, the thumbnail is my exasperation for the morning, Anne-Sophie. All right, let's finish this sucker off. You ready? So here we go. I got 34 electrons. How many are in bonds, gang? What do I take away? Hey, Oscar. I take away how many from the 34? Those are in bonds. Remember how we did this? So how many are in bonds? 4 single bonds, earth to class. How many in bonds? Believe your eyes. One lone pair. You may be way ahead of me, Bella. My question is, how many are in bonds? How many do I take away from the 34? Bella, you may be well ahead of me, but that's not my question. 4. Nah, Antonin, it's 4 bonds. How many are in each bond? How many do I take away from the 34 valence electrons? Okay, I got 6 plus 20, I got 34 valence electrons. I take away how many? There's 4 bonds. I take away 2 electrons per bond. Good, Chelsea, which means how many? I want all of you, all 13 of you, to be able to see this easily. How many do I take away? Hallelujah, 8. Okay, so I got 26 left. Okay, now, first satisfy the outer atoms. Now I got everybody. Thank you. There's probably some lag time there. So satisfy the outer atoms. You ready? Here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24. So Bella was right. I got 2 left. So I got an unshared pair left. Put it on the D. So I got 1 unshared pair. So I got 5 items around 1. Remember the picture for 5 around 1. It looks like this. Okay. So I got what? I got an F. I got an F. And then if we have unshared pairs, we put them out here. Remember on this trigonal dipyramid thing, we put them out here. So there's that, and there's another F, and there's another F. Back to our question. Is it seesaw or not? Please answer. Is it seesaw or not? Please answer. 1 unshared pair in a trigonal dipyramid. Bella says, yes, she's right. And you got to say that. Okay, so yes. In this, with 1 unshared pair, we use seesaw geometry. No, we get seesaw geometry. or seesaw shape of molecule, however you want to say it, okay? That's a good review question. Questions on that from you? Questions on that from you? Okay, I'm pausing just for a moment, and I'm going to erase it now. Okay, next question has to do with a big box of particles. And the box of particles, I'm not going to draw the whole thing, but it had this guy, that was F2, and there were 3 of them. And then there was this guy, and that's D, and there were 2 of them. And then it had this guy, and that's a DF4. And there were a lot of those. There were 10 of those. So altogether, in this box that you were given, I had this many particles. 2 plus 2 is 15 particles. Now, let's look at the question. You ready? We were supposed to do the entire FRQ section. Yeah, of course. Of course. And unfortunately, I can't choose FRQs that are only one chapter. They are mixed like this. I try to choose one that has as much kinetic stuff in as possible. But at this point in the course, you probably realize I gotta only use what the AP site has. Okay, and the AP test also has no pure FRQs. They're all mixed. But I try to choose the ones that concentrate on the subject at hand. Okay, let's look at the question. It says the P total is 12 atmospheres. And they want the pressure of D. The pressure of D initially. Initial. Okay. Well, here's what you got to do. You ready? You got to figure out how many little D particles there are. You ready? Watch this. Well, I had 2 here, but then all of these had D's too. So I got let me make sure I'm doing it right. No, that's question E. Sorry. I'm on the wrong one. Okay, so they don't want question D. That's question. They want just the P of D. So that's going to be easy. Check it out. I got 2 out of the 15. So I take 2/15 of 12 atmospheres. Why? Remember, the more particles of that type, the more of that partial pressure. So I've got 2 of these suckers that are D's out of the 15 total. So 2/15 of the pressure is from D. So I can about do that in my head, can't I? So I got 2 times 12 is 24. 24 over 15 atmospheres. Divide by 3, so I get what? 8/8 atmospheres. And now you math people can try and beat me. So it'd be what? 1.6 atmospheres. Ta-da! Okay, so it's just the number of particles divided by the total particles times the total pressure to get your partial pressure of D. Okay. Questions on D? E is the one I was trying to do before. So what's the initially in picture? Okay, so so the initial, they want the initial particles of F2 and D. In other words, you got to figure out how many F2s and Ds are in that sucker. You know what I'm saying? Okay, let's do D first. Well, for every one of these DF4s, there's a D in it, right? So I got 10 of them, so I got 10 Ds, and here I got 2 more, I got 12 Ds. Did I lose you? Instant replay. 10 of them out of the DF4s, and 2 more makes 12. F2s. Out of each DF4, I got essentially 2 F2s that came from there, okay? So I got 1, 2, and I got 2 for each one. I got 10 of them. So 2 times 10 is 20 of them, and I got 3 more. I got 23 of these. 23 F2s. I just counted up and went backwards, okay? And that's E. You're done. That's E. You just have to think about that. Okay, it was how many initial particles did I have of F2 and of D? So I just went backwards and added up all the Ds. I got 12 big dots, and I got pairs of dots. I've got 23 pairs of F2s. Just had to look back and count them. Okay, F says, I got a new equation, and it's D. So essentially, it's a new problem, I'll be honest. D plus, okay, no, it's not. It's the same equation. D plus 2 F2 makes DF4. And they gave me the delta H, which is negative 250 kJ per mole. And I guess it's mole as it's written, white, so 1D or 1DF4. And they want to know in F is if I got 0.74 moles or 75 moles of DF, DF4, what's the delta H? Now, be really careful, gang. They don't want the same delta H number. This is if I got 1 mole, but I don't. I got 0.75 moles. So what do I got to do with this amount of kilojoules per mole? What do I got to do? I want 0.75 moles of DF4. While I race up above, you guys think about it and write something. Okay? Okay, so what do I got to do here? I don't want 1 mole of it. I want 0.75 moles, and I want to see what the change in heat is. There you go. Thank you, Alicia. Multiply by 0.75. So I just got to do 0.75 moles times negative 250 kilojoules per mole. Be sure you have the negative because your final answer better be negative because it's exothermic, right? And we're running out of time, gang, so I'm just going to write the answer. I got negative 190 rounded. You guys can check my math. And we're on to G. And now I got a new equation. E plus F2 forms EF4. I must have 2 here. And I got a delta H of negative 150 kilojoules per mole. So notice it's less than. Okay? Exactly. Good. Penelope and Sophie and Licia all had that. Good. Okay, let's look at this one then. The question was, something like, is more, no, are the bond energies, is the bond energy of the products less than the other reaction, the DF4 reaction. I'm not sure if it's the exact same question, gang, all right? But I mean, that's kind of what they want to know is about bond energies. What you got to do is you got to say, oh, it's less exothermic. So what does that mean about the bond energies of the product? If it's less exothermic, the bond energies, instead of going down to here, they go down to here. You know what I mean? Let me do that in another way. Here, exothermic, right? Okay, instead of going down to here, let's say that's DF4. This EF4 one is less exothermic, so the bond energies are less. So I'm going to say in the EF4 bond energies are less than in DF4. And let's see what I wrote here in my little cheat sheet. So the DF bond energies greater. Yeah, that's what I wrote. Exactly. Okay, so that's kind of what you got to think about. If it's less exothermic, then the bond energies are going to be less than that one that's got a deeper, lower exothermic potential energy diagram. Speaking of, that's the last one, is a potential energy diagram. So because we're running out of time, I'm going to put this up and quickly do it. So H says I got PE, and I got some lines. And it says this one is I2, and then it says this one that's dotted is F2. And they say the F2 line is wrong. Why? Okay, remember about this diagram. I got potential energy on one side, and this axis, you ready? This axis is the distance between the two nuclei. Between nuclei. Well, here's the problem. Check this out. I is, on the periodic table, I is really big. So the nuclei are probably pretty far apart. F is really small. The nuclei are probably pretty close together. So you know what? They do have the depth right. They said it's a bit more, it's slightly a lower bond energy. Okay, fine. Bonding energy. So they said it's slightly lower. Yeah, but the placement's wrong. This sucker should be over here, shouldn't it? This F2 line. It should be to the left of I2 because F2 is really small. Its distance between the nuclei should be much smaller than I2. So F2 has correct depth for the bond. Remember, this is like where the bond is, this low spot, but is in wrong spot. The nuclei in F2 are closer than in I2. So, should be further left. So it should be left of I2 in the diagram. Let me read that off again. So in this sort of diagram, where I've got the distance between the nuclei and the potential energy, the low spot is where the bond is. And they said the bond was stronger in F2. Fine, it's a little deeper. But it's F2, man. These guys are really close, the two Fs. They're little tiny atoms. Here, they're much further apart. So the F2 needs to be inside or closer to this axis, so there's a smaller distance between the nuclei. Clearly, they're in the wrong spot, the F2 diagram. Oh, Lord. Okay. Well, we got about half done of what I wanted to today, thanks to our 2 crashes. Curse the internet anyway. I'll be glad when I see you live again. Theoretically, I'm going to see you next week. I hope that's the case. We don't have class Monday because it's Frauentag, but a week from Wednesday, I should be able to see you live in person at the high school. Let's hope that happens. So, yeah, in between time, I'm not going to start anything in 2 minutes. There's not much point. Let's see if you have some questions about this FRQ problem. Do they expect you to do all of that in like 20 minutes? Yeah. Do they expect every student to get every part? No. Remember, this is super hard. You're not going to get every single part right. Okay? You're not. You're not going to get 100% on it. You're just not. But if you get above like 60% or 70%, you got a high grade on the AP test. Okay? I had to put this on because I got to learn how to push you. You got to move fast. And you've got to be able to scan what's ahead of you and see if there's anything easier. If you can't get something, skip it and move on. There's my advice. All right. Well, thanks for rejoining me several times. And I'll see you on Wednesday. If you have questions on problems, write me, and I'll try to get back to you as soon as I can. Okay? All right, let's call that good for the day. Farewell, my people. I'll see you soon. Bye-bye.